Polamar 5 is a unique star cluster. This is firstly because it is one of the fluffiest clusters in the halo of our galaxy, with the average distance between the stars being a few light-years, comparable to the distance from the Sun to the nearest star. Secondly, it has a specular stellar stream associated with it that spans more than 20 degrees across the sky. An international team of astronomers and astrophysicists led by the University of Barcelona show that both distinguishing features of Polamar 5 are likely the result of an oversized black hole population of more than 100 black holes in the center of the cluster. Professor Marc Gilles, from the Institute of Cosmos Sciences of the University of Barcelona, the CUB, and lead author of the paper said that the number of black holes is roughly 3 times larger than expected from the number of stars in the cluster, and it means that more than 20% of the total cluster mass is made up of black holes. They each have a mass of about 20 times the mass of the Sun, and they formed in supernova explosions at the end of the lives of massive stars, when the cluster was still very young. Tidal streams are streams of stars that were ejected from disrupting star clusters or dwarf galaxies. In the last few years, nearly 30 thin streams have been discovered in the Milky Way halo. Professor Marc Gilles explains that they do not know how these streams form, but one idea is that they are disrupted star clusters. However, none of the recently discovered streams have a star cluster associated with them, hence we cannot be sure. So, to understand how these streams formed, we need to study one with a stellar system associated with it. Polamar 5 is the only case, making it a Rosetta Stone for understanding stream formation, and that is why we studied it in detail. The authors simulate the orbits and the evolution of each star from the formation of the cluster until the final dissolution. They vary the initial properties of the cluster until a good match with observations of the stream and the cluster was found. The team finds that Polamar 5 formed with the lower black hole fraction, but stars escape more efficiently than black holes, such that the black hole fraction gradually increased. The black holes dynamically puffed up the cluster in gravitational slingshot interactions with stars, which led to even more escaping stars and the formation of the stream. Just before it completely dissolves, roughly a billion years from now, the cluster will consist entirely of black holes. Gilles points out that they have shown that the presence of a large black hole population may have been common in all the clusters that form the streams. This is important for our understanding of globular cluster formation, the initial masses of stars, and the evolution of massive stars. This work also has important implications for gravitational waves. Polamar 5 is a globular cluster discovered in 1950 by Walter Baade. It is in the Serpens constellation at a distance of about 65,000 light-years, and it is one of the roughly 150 globular clusters that orbit around the Milky Way. It is older than 10 billion years, like most other globular clusters, meaning that it formed in the earliest phases of galaxy formation. It is about 10 times less massive and 5 times more extended than a typical globular cluster and in the final stages of dissolution.